For number 79, first they want us to find the inverse. So I'm going to write f of x. Okay, I'm just copying down the problem for the moment. Then I'm going to write it as y equals. Okay, it just helps with the notation. It's easier to write y. Alright, and then I'm going to interchange the x and y. Alright, and now I have to resolve it for y. So dividing both sides by 2. So it'll go away on the right side, leaving just natural log of y minus 1. Alright, now you don't have to do this next part, but just to emphasize, natural log means log base e. Okay. So I just rewrote the notation there. And then I'm just going to write, well, okay, so using the conversion, y equals b to the x again. If and only if log base b of y is equal to x. Okay, so I'm going to use this to convert the right side here. Let's see. Actually, the whole equation. So that means e to the power of x over 2 is equal to y minus 1. Add the 1 to the other side. And then just, I like my y on the left, so y equals e to the x over 2, and then plus 1. Okay, the plus 1 is not part of the exponent. It is outside of the e to the x over 2. Alright, so that is my inverse function. So f inverse of x is equal to e to the x over 2 plus 1. Okay, so that's part A. Part B wants us to use a graphing utility to graph f and its inverse. Okay, so let's see, let's come down here. Let's copy the original function down. Give me a second. So here's the original function. Where'd it go? I'll bring it back up. Alright, so the original function is on the right here. Alright, if you graph f of x on the calculator, it should look something like, and let me do it in red. Here's the asymptote. When x is 1, you'll get 0, so it's going to run through here at 2, and then it's going to do something like that. Okay. For the inverse function, let's see. When x is 0, you're going to get 2, so it's going to here, and the asymptote is going to be horizontal at 1, and do something like that. Okay, so this is f of x on the right, and this is the inverse graph. Alright, so now they want us to verify that f inverse of x and f of f inverse both equal x. Okay, so f inverse first, so part C. Let me copy both functions down here. So let's see, I need these two functions. Okay. And we want to know, they want us to first show that f inverse of f of x. Alright. So f inverse, f of x is 2 ln of x minus 1, which means we are going to plug that into f inverse. So let's see, e, and then 2 ln of x minus 1 divided by 2 plus 1. So I took this and I plugged it in for x. Alright, now I just need to clean it up. Alright, well the 2's are going to cancel, leaving me e to the power of ln of x minus 1 plus 1. Okay, and then you want to note, okay, it's not that they're really canceling, but when you have e to the ln, you can think of that as going away and leaving just the x minus 1. Okay, whatever the argument is. Okay, so now it does come down out of the power. So it's x minus 1 plus the 1. The 1's cancel, leaving you just x. Okay, so now we want to do f of f inverse of x. Alright, well, f inverse is e to the x over 2 plus 1. And I'm going to take that and plug it into f of x. So it's going to read 2 ln of e to the x over 2 plus 1 minus the 1. Okay, so I took this thing and I plugged it in for x. Alright, so now I have 2 ln. In here I can drop the parentheses, so it's just e to the x over 2 plus 1 minus 1. The 1's will cancel, leaving e to the x over 2. Alright, now another note, when you have ln of e, let me just circle it in red, then the exponent just comes down. So now it's 2 times x over 2 directly. The 2's are going to cancel, leaving you x again. And that's what you were supposed to show, that both of them got you just x. Alright, so that is the end of all of that for number 79.